So this will be part 2 of the final exam review. And the first few problems are the problems that we're going to solve by rewriting each side with the same base, and then we're going to drop the bases and set the exponents equal to each other. When I do this, each one of the sides is going to be a power of the other's base. And in this case, the 27 is a power of 3. So I can rewrite this problem as 3 to the x minus 3 equals 3 cubed. And when I do that, I can drop the bases and set the exponents equal to each other. So now I'm going to cancel out those bases, set the exponents equal to each other, and I'm going to solve for x just by adding 3 to both sides. So my answer to problem 21 is just going to be x equal to 6. I could check that. I kind of checked it in my head. I feel good about that answer. Lots of junk on problem 22. First of all, I have to know that 1/8 can be written as 8 to the negative 1 power to help each side not be a fraction. Similarly, I'm going to write 1/2 as 2 to the negative 1 power to get started. So fractions are certainly not my friends here. So I'm going to write the left side as 2 to the negative 1 power to the x minus 2 power. And the right-hand side, I'm going to write it as 8 to the negative 1 power. And I'm going to put that negative 1 outside of parentheses because I'm going to need to give the 8 another exponent. So first step, get some negative exponents, get rid of the fractions. And now I'm going to make the 8 on the right-hand side into 2 cubed because 2 cubed is equal to 8. So I can rewrite this as 2 to the negative 1 to the x minus 2 equals 2 cubed to the negative 1. And now I'm going to clear the parentheses by multiplying the exponents. The 2 on the left-hand side, I'm going to go negative 1 times x and negative 1 times negative 2. And I'm going to get an exponent of negative 1x plus 2. On the right-hand side, I'm going to multiply the exponents 3 and negative 1 and get negative 3 for the base of the 2. Now both sides have the same base, so I could cancel out the bases, even though the 2's are written differently, they're both 2's, and set the exponents equal to each other. So it's going to give me negative 1x plus 2 equal to negative 3. I'm going to minus 2 from both sides and get negative 1x equals negative 5. And then I'll divide both sides by negative 1 and get my answer of x equal to 5. If you want to check this, because it's kind of a hard problem, to check, I would go to the original problem and change the x to 5. So for checking, it's completely optional, but it should be the case that 1/2 to the 5 minus 2 power would have to be 1/8. On my calculator, I'm going to work that exponent down a little bit, and I'm going to enter 1/2 cubed to make sure that that's 1/8. So easy enough to check, so I'll do it. I'll go parentheses 1 divided by 2 up arrow cubed, and then math, enter, and I get 1/8 equals to 1/8. So I know my answer is perfect. All right, so for 23 through 26, I'm going to have to get rid of the logarithms. On 23, when I cross out the logarithm, I'm going to create an equation that has an exponent. The 2's going to stay on the left-hand side. The equal sign's going to stay where it's at. The x plus 1's going to move to the other side of the equal sign and not need the parentheses anymore. The 5 is going to move to the left-hand side, and it becomes an exponent because I'm creating an exponential equation. This is going to give me 2 to the 5th equals to x plus 1, which is really 32 equal to x plus 1. And I'll solve that by minusing 1 from both sides, and I get 31 equal to x for my answer. If I want to check, it's not particularly hard to check. To check, it should be the case that the log base 2 of 31 plus 1 equals to 5. And I'm going to do a little math in my head before I use my calculator. Get the log base 2 of 32 equal to 5. And on my calculator, I'm going to enter the log of 32 divided by the log of 2. And make sure that that's equal to 5 because that's simplifying the left-hand side, and for an answer to be correct, the left and the right-hand side have to be the same. And that gives me exactly 5 equal to 5. So I won't check all of these just because I have the answers next to me so I can know whether they're right or not. This is just to refresh your memory on how to check these in case you forgot. 24 is just about the same problem. So I'm going to scratch out the logarithm. The 4 is going to remain on the left-hand side. The equal sign is going to remain where it's at. The 3 is going to move to the left-hand side and become an exponent. The x minus 5 is going to move to the right-hand side and won't need the parentheses. 4 cubed, if you need your calculator, use your calculator to do that. That's 64. So this gives me 64 equals x minus 5. And I'll just add 5 to both sides and get 69 equal to x for my answer. Next problem I'll check because it's a little bit trickier problem. So on 25, I need to get the problem written with one logarithm, and I'm going to use the rule that says if two logarithms have the same base and they're separated by a minus sign, you can make those two logarithms into one logarithm by forming a fraction. So I use the minus to divide rule to make the two logarithms into one. And now I'm going to cross out my logarithms again. The 2 is going to stay on the left-hand side. The equal sign is going to stay where it's at. The fraction is going to move to the right-hand side. The 1 is going to move to the left-hand side and become an exponent. So this technically gives me 2 equals to x plus 14 over x plus 6. I want to solve this by cross multiplying, so I'm going to write the 2 as a fraction by writing it over 1. Now I'm going to cross multiply and get 2 times x plus 6 equals 1 times x plus 14. This will give me 2x plus 12 equals 1x plus 14 when I clear the parentheses. Now I'm going to minus 1x and minus 12 from both sides. When I minus 1x, I get 2x minus 1x, which is x. When I minus 12, they cancel on this side. On this side, when I minus 1x, they cancel. When I minus 12, I get a 2. That's going to be my answer. The answer to problem 25 should be x equal to 2. I should check it, and I'm going to use my calculator to check it because it's much easier. So I'm going to squeeze my checking right up here. For my checking, it needs to be the case that the log base 2 of 2 plus 14 minus the log base 2 of 2 plus 6 equals to 1. I'll do a little math in my head. I'm going to make this the log base 2 of 16 minus the log base 2 of 8. That equals to 1. I'm going to do this on my calculator. So on my calculator for that, I should go first log. I go log of 16 divided by the log of 2. That's the first logarithm. Then I put the minus sign. The second logarithm, I do log of 8 divided by log of 2. When I hit enter, it better give me 1. If it doesn't give me a 1, I have a mistake. But it gives me the 1, so I know my answer is right. So my answer, x equal 2, is correct. 26 is the bad one. It's the only problem on the review that you could do perfect algebra and generate an answer that doesn't check. You get an extraneous solution. This problem is going to generate 2 answers, but only one of them checks. First step, I need to make the left-hand side only have one logarithm. Because the logarithms have the same base and there's a plus sign between the logarithms, I could make the 2 logarithms into one logarithm by using the addition to multiply rule and multiply their arguments. I need to do that multiplication that I just showed up. First are going to be x times x, x squared. Outers are x times 6, which is 6x. Inners are 2 times x, which is plus 2x. Lasts are 2 times 6, which is plus 12. This is going to give me the log base 2 of x squared plus 8x plus 12 equals to 5. Now I need to cross out the logarithm like I did for the last 3 or 4 problems. The 2 is going to remain on the left-hand side. The 5 is going to move to the left-hand side and become an exponent, and the polynomial is going to move to the right-hand side. Because there's an exponent with one of the x's, I'm going to have to get this problem set equal to 0, and I'm going to need to solve by factoring. The 2 to the 5th on the left-hand side is 32. I need to get the problem set equal to 0, so I'm going to minus 32 from both sides and get 0 equals to x squared plus 8x minus 20. I'm going to factor that into x plus 10 times x minus 2. I'll go x plus 10 equal to 0, x minus 2 equal to 0, and get x equal to negative 10, which won't check, and x equal to 2, which will check. So for my checking, let me check the 2 first, and I'll try to just squeeze it in here so I get it all on the same page. So the check, first I'm going to do x equal to 2, and go the log base 2 of 2 plus 2 plus the log base 2 of 2 plus 6, and that has to equal to 5. I'm going to simplify this a little bit before I use my calculator. I'm going to get the log base 2 of 4 plus the log base 2 of 8 equals to 5. Now I'm going to pull out my calculator. For the first logarithm, I'll do log of 4 divided by log of 2. And then I'm going to use this plus sign. And then log of 8 divided by log of 2. When I hit enter, it's simplifying the left-hand side. It better give me 5 because that's what the right-hand side is. So I know that's okay for an answer. The negative 10 is not going to work because logarithms with negative numbers give i's, and my calculator doesn't even know how to do those. So I go log base 2 and then plug in negative 10 for x of negative 10 plus 2 plus the log base 2 of negative 10 plus 6, and see if that equals to 5. I'll simplify this to make my calculator button pressing easier. Do the log base 2 of negative 8 plus the log base 2 of negative 4 equal to 5. And what's going to happen is I'm going to get something with an I that my calculator doesn't know how to compute, but it's going to come back and say non-real answer. And the left that tells me the left-hand side, when it simplifies, has an I, and a number that has an I can't equal to a number that 5 that doesn't have an I. So that error message right there tells me that this side has an I. It says non-real answer, means it has an I in the answer, and that doesn't equal to something that has a 5 without an I. So the only answer is x equal to 2. If you write the negative 10 down, you're going to lose a point or two on the test because it doesn't check. And it's the only problem. The logarithms, 2 logarithms with a plus between them, are the only problems that you have to worry about getting an answer that doesn't check. All right, 27, ugly fractions. Says to solve using the substitution method. I should clean up the top equation. So I'm going to get rid of the fractions in the top equation to get started. To do that, I'm going to go 20 times 4/5 x plus 20 times 1/4 y equals 20 times 5. This is going to give me 80 over 5x plus 20 over 4y equals 100 by multiplying through. And then 80 divided by 5, I think it's 16. I just did it off my screen here. This is going to give me 16x plus 5y equals 100. Now I'm going to substitute. Real specifically, I'm going to take the x in this equation and change it to y plus 1 using the bottom equation. So I'm going to go 16 times y plus 1 plus 5y equals 100. Clear the parentheses and get 16y plus 16 plus 5y equals 100. Add the 16 and 5y and get 21y plus 16 equals 100. Minus 16 from both sides and get 21y equals to 84, and then divide by 21 and get y equal to 4. Now I'm going to solve for x using that equation. So when I go to solve for x, I'm going to use x equal to y plus 1 and plug in 4 for y. So I'll get x equal to 4 plus 1. I get x equal to 5. And in these systems of equations, we write the answer as a point. The x is going to go first. The y is going to go second. So I'm going to say the solution is 5, 4. (28) wants me to solve using the elimination method. I need to add the equations together and drop out a letter. I'm going to drop out the y's because the y's have opposite signs. I'm going to make the top have a positive 12y and the bottom have a negative 12y so that I can eliminate the y's. To get that to happen, I'm going to multiply the top equation by 4, the bottom equation by 3. Multiplying the top by 4, I get 8x plus 12y equals to 52. And multiplying the bottom by 3, I get 15x minus 12y equals to 63. Now I'm going to add the equations together. This side's going to give me a 23x. The y's are going to cancel. This number is 115. And then I'll divide by 23. You can do this on your calculator if you can't know that that's 5 in your head. This gives me x equal to 5. Now I need to solve for y. And I can use any equation. I'm going to use the equation 2x plus 3y equal to 13 because the y is positive and the numbers aren't that big. I'm going to go 2 times 5 plus 3y equals to 13. That's going to give me 10 plus 3y equals to 13. And then minus 10 minus 10. That's going to give me 3y equal to 3. And then divide by 3. Divide by 3. I'm going to get y equal to 1. My answer, I'm going to write 5, 1. You write them as a point, x first, then y second. (29) is not so fun. I'm supposed to solve a system that has 3 equations and 3 unknowns without matrices. So how am I going to do that? Well, it says pair the middle equation with the other 2 and drop out the x's. So I'm going to take the middle equation, negative x plus y plus 2z equal to 7, pair it with the top equation, 2x plus 4y minus 5z equals negative 5, and take the middle equation, negative x plus y plus 2z equal to 7, pair it with the bottom equation, x minus 3y plus 3z equal to 4. I'm going to need to do the elimination method 3 times. This is 2 of the 3. For the first pair to drop out the x's, I'm going to multiply the top equation by 2 and get negative 2x plus 2y plus 4z equals to 14. I'm going to leave the bottom one, 2x plus 4y minus 5z equals to negative 5. When I add these together, the x's cancel. I get 6y minus 1z equals to 9, if I do that math right in my head. The next pair you can just add together to drop out the x's. When you add them together, the x's cancel. 1y minus 3y is minus 2y. 2z plus 3z is 5z. 7 plus 4 is 11. Now I'm going to do the elimination method with the 2 equations that I just created. So I just created 2 equations. I created the equation 6y minus 1z equals to 9 and negative 2y plus 5z equals 11. I'm going to drop out the y's by multiplying the bottom equation by 3. You can drop out the z's by multiplying the top equation by 5 and get the same answer in a slightly different order. So I'm going to leave the top 6y minus 1z equal to 9. I'm going to make the bottom minus 6y plus 15z equals to 33. Now I'm going to add these together. This is going to give me a 14z. This is going to give me a 42. I'm going to divide both sides by 14. I don't need a calculator to do that, but you can use your calculator to get z equal to 3. Now I'm going to solve for y. I'm going to use 6y minus 1z equal to 9 because it has a positive y. I could use the other one, but it has a negative y. This is going to be 6y minus 1 times 3 equals to 9. That's 6y minus 3 equals to 9. I'm going to add 3 to both sides and get 6y equal to 12. Divide by 6 and get y equal to 2. Lastly, I need to solve for x, which means I need an equation with an x. I'm going to use that equation, but I could use any equation that has an x just because it has a really nice x. So I'm going to use the equation x minus 3y plus 3z equal to 4. And into that equation, I'm going to plug 3 for z and 2 for y. So I'm going to get x minus 3 times 2 plus 3 times 3 equal to 4. That's going to give me x minus 6. Oh, wow. X minus 6 plus 9 equals to 4. That's going to give me x plus 3 equal to 4. And then I'm going to minus 3 and get x equal to 1. When I go to write my answer, I'll write it as an ordered triple in order x, y, and z. My answer is going to be x equal to 1, y equal to 2, z equal to 3. When I go to write my answer to this problem 29, I'm going to write x equal to 1, y equal to 2, z equal to 3 as an ordered triple. All right, just a few more problems. 30 looks like it has ugly answers. And it's going to have ugly answers. There's kind of no way around those ugly answers. I'm not feeling good about this, but there's not much choice. So when there's x squareds or y squareds, you can't use the elimination method. You have to use substitution. What I'm going to do is I'm going to solve the top equation for x and substitute it into the bottom equation. I get 2 answers for this. So first step, I'm going to take this top equation, x minus 7y equal to negative 4. Now I'm going to solve it for x by adding 7y to both sides. This is going to give me x equals to 7y minus 4. And now in the bottom equation, I'm going to change the x to 7y minus 4. And I need to do that in a parentheses. Now I'm going to clear that parentheses by foiling. This is worrisome that I'm going to get a problem that's going to be out of control. So I get 49y squared minus 28y minus 28y plus 16 when I FOIL that. And then plus 1y squared equals to 10. I'm going to add the 49y squared and 1y squared and get 50y squared. I'm going to combine the minus 28y and minus 28y and get minus 56y. And I have a plus 16 equals to 10. I'm going to minus 10 from both sides. Horrible numbers. And get 50y squared minus 56y plus 6 equals to 0. I can divide all this by 2 to make it a little more tolerable. Anytime you have a numerical common factor without an x and an equal sign, you can divide that common factor away. So this gives me 25y squared minus 28y plus 3 equals to 0. And I'm going to factor this using bottoms up factoring because it's a lot easier for me to factor than using the quadratic formula. So for bottoms up factoring, so I'm going to do this off on another sheet of paper. I'm going to bottoms up factor the 25y squared minus 28y plus 3. First step, multiply by 3 and rewrite. So I'm going to multiply those together and get y squared minus 28y plus 75. Second step is to factor. This is a double minus factoring. My lasts need to multiply to 75 and add to 28. That's 25 times 3, because 25 times 3 is 75, and 25 plus 3 is 28. And now I'm going to divide by 3, reduce, and bottoms up. Actually, I'm going to divide by 25 because I started off multiplying by 25. So I'm going to divide that by 25 and that by 25. That's going to give me y minus 1 times 25y minus 3. So that's what I'm going to throw right back to my other sheet of paper. So I did this all off to the side to make my work easier to follow, I guess. So this is going to give me y minus 1 times 25y minus 3 equals to 0. Now that I have this factored, I need to set each factor equal to 0. Setting the y minus 1 equal to 0, you get y equal to 1. Setting the 25y minus 3 equal to 0, you add 3 to both sides and get 25y equal to 3. And then you divide by 25 and get y equal to 3 over 25. So I have two answers for y's. Each y needs an x, and I'm going to use this x in my calculator if I need to use my calculator. So each y needs to be paired with an x. So the y equal to 1, I'm going to go x equals to 7y minus 4. X is going to be 7 times 1 minus 4, which is 3. So one of my answers is going to be the point 3, 1. The other y, I'm going to go x equals 7 times 3 over 25 minus 4. I don't care to do that by hand, and I don't need to do it by hand. So I'm going to go x equals 7 parentheses 3 divided by 25 minus 4. Math, enter, enter, and I get negative 79 over 25. And as a solution, that's going to be negative 79 over 25 for x, 3 over 25 for y. I have the answers right next to me, so that is, I checked it by glancing at the answers. That's perfectly correct. All right, just 2 more problems to get through, and we're done with the entire review. For problem 31, I can solve the top equation for x to use substitution or the bottom equation for y. I'm not sure which one is easier. I get 2 answers again, and one of them is an ugly fraction. Let me just solve the top for x. Oh, it's not going to be so good. Let me solve the bottom for y. So I'm going to solve the bottom for y to get started. So I have x squared plus y equal to 13. Easy enough to solve this for y. I'm just going to minus x squared from both sides and get y equals negative x squared plus 13. Now I'm going to, in the top equation, take that y and change it to minus x squared plus 13. I need that minus there. So this is going to give me x plus 2 times minus x squared plus 13 equals 11. We do that multiplication, I get x minus 2x squared plus 26 equals 11. I need to get it set equal to 0 because of the x squared. The best thing to do is go minus x plus 2x squared minus 26 to get the x squared to be positive. By minus x plus 2x squared and minus 26 on the left-hand side, I get a 0. On the right-hand side, the 11 minus 26 is going to give me a minus 15. And the other two pieces, 2x squared minus x, I'm just going to write first. I need to it's another bottoms up factoring that I'm going to do on a separate sheet of paper. So I'm going to bottoms up. So I'm sneaking a couple bottoms up in here just in case you're going on to calculus, so you don't have completely forgot that. So I'm going to multiply by 2 and rewrite. It's going to give me x squared minus x minus 30. Then I'm going to factor this, which factors into x plus 5 times x minus 6. Then I'm going to divide by 2 reduce in bottoms up. First one comes out to 2x plus 5. Second one comes out to x minus 3. So right back in my problem, I'm going to change this to 0 equals to 2x plus 5 times x minus 3. Done with my bottoms up factoring. I'll throw this piece of paper away. Now I'm going to set 2x plus 5 equal to 0. This gives me 2x equals to minus 5, x equal to minus 5 halves, and set x minus 3 equal to 0, and I'll get x equal to 3. For each x, I need a y, and I really need to think of this as y equals to negative 1, x squared plus 13 when I go to find the y's. So for my first y, I'm going to go y equals negative 1 times negative 5 halves squared plus 13. And I'm going to do that on my calculator because I don't want to do that by hand. So I'm going to go negative 1 parentheses negative 5 divided by 2 squared plus 13. Math, enter, enter, and I get 27 over 4 for the y. So that's going to give me one of the answers, negative 5 halves for x and 27 over 4 for y. I'll just squeeze the answers right here. So one of the answers is x equal to negative 5 halves, y equal to 27 over 4. The other one, when I plug x equal to 3 into this, I'm going to get y equals negative 1 times 3 squared plus 13. That's going to be negative 1 times 9 plus 13. That's negative 9 plus 13, which is 4. That's going to give the answer x equal to 3, y equal to 4. All right, one last problem guaranteed to come up during the first week of calculus, at least during the first 2 weeks of calculus. So that's why it's shoved here at the end of the video, just to make sure when you get to calculus, at least you've seen this. So what I'm going to need to do is figure out what f of x plus h is and what f of x is, and change in the difference quotient f of x plus h to what it's equal to and f of x what it's equal to. F of x plus h is going to be x plus h squared plus 3 times x plus h minus 5. So the difference quotient is this formula, f of x plus h minus f of x over h. To find the difference quotient, you have to get out of function notation into non-function notation. To figure out what f of x plus h is in non-function notation, you change both those x's to x plus h. This is going to be x plus h times x plus h plus 3 times x plus h minus 5. Foil this. X times x is x squared. X times h is plus 1xh. H times x is plus 1hx, which I'm going to write 1xh. H times h is plus h squared. 3 times x is plus 3x. 3 times h is plus 3h. And the minus 5 is the minus 5. This whole thing comes out to be x squared plus 2xh plus h squared plus 3x plus 3h minus 5. In a bit, I'm going to take this whole thing and change it to that, because that's what these are equal to each other. F of x is not so hard to figure out what it's equal to. The f of x is equal to x squared plus 3x minus 5. And in a second, I'm going to change this symbol to x squared plus 3x minus 5, but it absolutely is going to need to be in a parentheses. So to find the difference quotient, f of x plus h minus f of x over h, I'm going to make a big fraction. I'm going to write all this first. X squared plus 2xh plus h squared plus 3x plus 3h minus 5. And then I'm going to put a parentheses and then minus x squared plus 3x minus 5 all over h. Notice that I kind of wrote that high because I'm going to clear the parentheses to save a line of work. So after this should be that in a parentheses. When I clear that parentheses, I'll get minus x squared minus 3x and plus 5, because clearing a parentheses caused me to switch signs. Now a lot of things are going to cancel, which is a great thing. This x squared and this minus x squared cancel. This 3x and that minus 3x cancel. And this minus 5 and that positive 5 cancel. What I have left that doesn't cancel, I'm going to write down. So I'm going to get f of x plus h minus f of x over h equals to 2xh plus h squared plus 3h over h. Now I'm going to factor out an h as a common factor from the numerator and do a 1 parentheses factoring. When I factor out an h, from there I'm left with a 2x. From here I'm left with a plus h, and from there I'm left with a plus 3. Now I'm allowed to cancel the common factor of h with the h in the denominator. I've canceled the entire denominator, so my answer doesn't need to be a fraction. The answer to this is going to be what the numerator is, and without the parentheses. The difference quotient, the answer to the last problem on the review, is going to be 2x plus h plus 3. A really big deal right at the beginning of calculus, so it's a really good problem to not forget between now and when you take calculus. If you don't take calculus, you're never going to see a difference quotient. All right, so that's the entire review. Always, if you can do every problem on the review, then you should be perfectly ready for the test. So the final exam can't have more than 32 problems. It probably has 25 problems would be my guess. So there's about 7 extra problems that I likely did.